This is our old Janitrol unit. If you go back a couple years on my videos to a video called The Dying Janitrol, had a bypassing reversing valve. It was bleeding gas through it. Real low in charge. Had an evaporator with several leaks on it. That is this unit. So now we have the SSZ 14 in place. I'm going to level it up. Then I'm going to move on with the installing process. I like to use these sort of vibration pads underneath the outdoor unit sometimes, because you can actually take and separate the rubber part from the cork part. So if you want like a 3/4 to 1 inch rise, you can put a whole pad underneath it, or you can rip the little pieces apart just to get a little bit like a 1/4 inch rise out of it to level things up. They work pretty good. Usually buy them in bulk 48, but they come in real handy. This is our indoor coil. Came off the top of the electric furnace. Old Mortex coil. Was leaking in about 100 spots. I remember running a leak detector across this thing a couple years ago, the yellow jacket leak detector, and just everywhere, beep, 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 everywhere. Definitely a leaker. She's a couple years late getting removed, but that's how it is with rental properties. This is our new, much healthier looking Mortex coil. What we can do is we can take that TXV equalizing port over to here. For some reason, when I put these things in with TXVs, I keep brazing in that fitting that comes with TXV kit, which is right here. That has the flare on it for the equalizing port. When I don't realize it, or I don't pay any attention to it, the fact that there's a port on this thing that I could use, well, maybe this time I'll remember. This is the kit of stuff that comes with our Mortex coil. Some technical information. Of course, we don't need that. Insulation, some drain piping. They give you this kind of cheap little connector. You can put the PVC. Truthfully, when you get into Mortex coils, there's all sorts of drains. There'll be some black ABS drains. There'll be some vinyl tubing drains. So you're just going to have to get there and figure out what you got to do to connect them. It's not always perfect, and it's not always as wide as, say, a 3/4 inch PVC. But you see, these fit together. But we'll get that worked out. It's always different on each one, it seems like. It's never just hook it up and goes. There's always something. This is our Mortex coil in place, sitting on top of the very healthy looking electric furnace. Pay no mind to that large rusty area right there. Making sure to put our drain fitting in place, because once all our lines are tied in, it'll be real hard to screw that 90-degree drain fitting in place. This black tubing, we can actually pull it up. It'll go over the top of the drain fitting and be crimped in place with a little pipe clamp they send with you. So that looks like it'll work out just fine. I had to blow out that drain before we do that and blow out these lines, but that is no problem. We finished soldering up the evaporator here. Got the TXV in. Got it tied in up at the top of the coil, equalizing line. Not completely done. I put a little shroud on it. It goes right here. A little pain in the ass shroud they give you. And gotta anchor the bulb. I'm gonna pressure test before I do all that, so I won't be ripping anything off as far as insulation or bulbs to braze again. Now I'm heading outside. I finished brazing up the outdoor unit. Got a couple of rags wrapping the service valves. Brazed back to the original line set there. Do a little bit of straightening through here. Put our insulation on once the pressure test is done. Because this customer bought a scratch and dent unit, I will be making a repair here as well. The outdoor coil came from the factory with a leak in it, so we are going to repair that leak and then pressure test the entire system. We're going to take the top off the unit now, so we have to take the 3 wires off the fan motor. Have the black wire disconnected off the defrost board here. We'll take the other 2 off the capacitor. We see our brown and purple wires. We'll take those off, then feed them back down through the hole here, and we'll be able to pull the top off. If we look at this U-bend right here, you will see that it is leaking. I did a nitrogen test on it, and you can actually hear it leaking. I don't know if you'll be able to hear it here, but you can see there's a little bit of sloppy brazing right there anyway. So we're going to rebraze that U-bend, and that should be the only problem we have out here with this unit. And that's totally worth 80% off. This is the view from the other side of the U-bend. You can see it just looks like a very sloppy joint. There's a big old wad right here on top It almost looks like someone came behind it and tried to rebraze it or something like that. We're going to take it and clean it up and run some new silver solder around through there and seal everything up real nice, and we should be good to go. Here's a picture of the rebraze. Braze the top and bottom again. Man, it looks pretty good. A lot of work at the Goodman factory. We have nitrogen pressure on the heat pump right now. 150 pounds, a little bit over 150 pounds. So we will let it sit here for a while, make sure our joint is good, and then we'll test the rest of the system, button things back up because there's no power yet here at the house, and come back whenever they turn the power on to charge everything up. I am now putting nitrogen on the rest of the system, hooking the Hillmore gauges here up to our line set. We will put about 50 to 100 pounds on it to start with, see if there's any major leaks, and then move on. We're at the furnace now and the coil, just making sure I don't hear any leaks. It appears we are just fine as far as audible noise. I'll go ahead and finish this up as far as pressure testing, and then I can finish trimming out this TXV, hooking up the bulb. I have finished wiring up the low voltage. The high voltage needs a couple more components. Needs some seal tight, some fittings for that. I have to bring those back, or have him do it really. I've wired up the low voltage, 5 wires coming in. You have a white W2, you have a red for 24 volt hot, you have a blue 24 volt common, an orange reversing valve, and a yellow typically, but on the Goodman condenser it's like a bluish wire with a red stripe. It's for the contactor. So we're ready to get finished up, just no power here, so we're going to leave it here with nitrogen pressure on it until power gets applied to the building. Then we'll finish up charging it and starting it up. I got the vacuum pulling on this unit over here on the trailer. It's been about 2 weeks since we installed the unit. Getting ready to start things up, get things ready to roll. Get this sucker cooled down for the tenant that's moving in tomorrow. Have the R410A out, putting refrigerant into the unit. As you see, we are about a pound into it. 11 pounds total, probably go to about 10. We have a very short line set. This is a single wide trailer, so the line set, you know, goes right through the wall, and boom, you hear that click. That was a low pressure switch going in. Line set goes right through the wall, right to the electric furnace and coil. So we'll start with 10 pounds and go from there. Get our proper subcooling. We have a TXV on the inside because this is an SSZ 14 and requires a larger Mortex coil equipped with a TXV. I wanted a good housing to put my I-manifold probes into a safe spot, so I went to Dick's and got this gun case. It's a pistol case. To tell you the truth, I think they got the idea from watching, I think it was Fritz actually, with his vacuum supplies, if I remember correctly. That stayed in my mind. So I knew this would be a good thing for the probes to keep them safe. And there's enough room in there. I can fit 2 probes and a 3rd probe, or a repeater probe, or one of them low pressure ones. However I want to fill out the case there. Probably a repeater probe. But I thought it'd be a good idea. And they're pretty cheap. I think it's like 15 bucks for a gun case, $10 or $15. So cheap way to keep them protected and keep them from being broke. We have about 7.5 pounds in there. That's all it'll take. It was going real slow, so I'm going to start the system up, let it run. Put the rest of the charge in there, and we'll fine-tune the subcooling, check our superheat, and see how we're doing. We have our system all started up. You see we have a 327 over 167 refrigerant pressure, and you know it's hot inside if it's almost 170 pounds on the suction side. We have a TXV inside. You see we're about on target as far as the suction pressure. TXV is actually regulating that. We don't have much subcooling. We'll have to put in some more refrigerant. As you see down here, we have 0.8 subcooling, and the head pressure is a little off because we only have just under 8 pounds of refrigerant in the machine, and it requires almost 11 according to the data plate. But we're going to pump it up with refrigerant. This is the inside of the single wide. Lieutenant's moving in tomorrow. There's our supply air probe. On the closest supply grill, we have our return air probe skillfully tucked in between the return grill fins. And that's a pretty good location for these. Most of these trailers have 3-ton units on them because the heat loss, or heat gain should I say, in these walls is substantial. You'll have walls that are insulated to 1/3, at the best a half as good as a standard house. Most of the time when you shut these ACs off, you can feel the heat creeping back in through the walls. A lot of them have 3 tons, but none of them have the ductwork for 3 tons. And none of them have the ductwork to really support 2.5 tons. That's what we have here, because all of the 3-ton machines are just choked off for air. See, there's 1, 2, 3, 4, 5, 6. I think there's 7 outlets in the entire trailer, and of course the ductwork's small aluminum rectangular ductwork. But it is what it is. That's the way it goes. But using 2.5 instead of 3 is a much better way to go, because you'll actually get a better flow through the machine as far as AC. But I'm gonna head back outside. We're putting refrigerant in the machine and should be wrapping it up here shortly. We'll let it run for a while, but everything's going as we just got done putting in the 11 pounds of refrigerant. We have our return air temperature dropping down pretty steadily. We have 1.6 degrees of superheat. We'll see if that comes back up. If it does not, we will adjust the TXV. That will increase the superheat and subcooling, basically throttling back the TXV so more of the refrigerant stays on the condenser side, raising the subcooling, and less of it makes it to the evaporator, which will raise the superheat. But right now they might adjust out. We're going to give it a few minutes and either wrench it back, which will probably be the case, and let's see if we have to add any more refrigerant. It looks like I didn't have to cut the TXV or adjust it back. Right now we have 9.7 degrees of superheat. The TXV is actually regulating the superheat, cutting back the refrigerant flow. As you see, as it cuts it back, we have 10 degrees of superheat now. We get a greater subcooling. The TXV is restricting the flow of refrigerant into the evaporator, forcing it to back up into the condenser. Get a higher head pressure, higher subcooling. Basically doing its job. So we'll see. We might be just adding a little bit more refrigerant, but I'm going to wait to see how it planes out here over the next 5 minutes. It's been running like this for about 5 or 10 minutes, so we'll give it a little bit more time, and then we'll make adjustments from there. Well guys, just let the TXV do its thing. It's been about 15 minutes since we started. Looks like we're going to end up in a pretty good spot. We have a 335 over 143 running pressure, 12 degrees of superheat, 8 degrees or almost 9 degrees of subcooling. About right on target for where we need to be. Our head pressure is a little shy of where we need to be, but we are pretty close, and I think we're doing pretty well actually. So we can't really check the system performance right now because it has to be within a certain temperature parameter as far as return air, and we are too hot still. I will wait a little while and maybe we'll get down there before we're done testing. I hope we do. If we do, I will show you guys. Otherwise, I will see you guys on the next one. As you can see guys, the subcooling is a little high. We didn't actually adjust anything yet. We've run it for about 25 minutes. Our subcooling is 14.5. I'd like to see it a little bit lower than that. We can adjust our TXV, bring the subcooling down and the superheat down, which is where it needs to be. So we'll go ahead and make that adjustment inside and see how it works out here. As you see, with the pressures are very low, and they changed quite a bit because I took the door off. Our suction pressure plummets. Everything changes, so we'll let that settle out, let it run for a few more minutes, check and see how the TXV responds. As you see, after we made our adjustment, we have a little bit better as far as superheat subcooling. 12.4 subcooling, 11.4 superheat. You can see here, that's where I took the door off to adjust the TXV. You can see the sharp dip in superheat as air bypassed the coil. And there's also a dip on the subcooling chart, but it stayed relatively on target the whole time. So hopefully we're about done here. As we see, our superheat has bottomed out a little bit lower. Our subcooling is definitely lower. So we're about squared away. Hopefully happy for today. May make a few more adjustments, but I think we're pretty much done. And I'll see you guys on the next one. I bleed for my money, day in and day out. I try to give you the things you deserve, but I'm just a college dropout who gives his weeks to break the mean, falls in the tide line, is washed out to sea. When I see the sunshine coming, if I weren't a worker, that was right.